so I just want to start off by obviously thanking everybody for joining us this morning, taking the time out of your busy schedules to come and support us in our first webinar. So yeah, this, as Emily said, is just going to be a sort of a high-level overview of the progression of the drone survey industry, and yeah, essentially how we can make the industry work for you, and yeah, how you can get stuck in. Cool. So I just want to start by giving a quick overview of Ether as a company for those of you that don't know us. I know we've got quite a few companies that we've worked with before in the webinar today, but for those of you who don't know, Ether are a drone solutions provider. So we will work with businesses right from the conception of the idea to start using drones, all the way through to the sort of training side, supply side, development and expansion of drone operations within businesses. So we like to take the time to welcome everyone who's not currently had any interaction with us before. And yeah, just a quick note, if anyone at the end of this session would like to book in for a meeting, contact details will be available at the end of the session. So in the surveying industries, drones can be used to cover a wide variety that is growing day by day. So the agricultural sector, we're seeing a lot of uses of imagery from drones to essentially save the time of identifying what is going on in the land that is owned by farmers. As if you have an eye in the sky, obviously the data that you can collect aids decision making, which is going to be a theme that you'll see throughout this. So essentially, drones as a method for data capture is the name of the game, and the primary way in which we're going to start sort of seeing savings through the use of drones. In the agricultural sector, obviously, there are a lot of developments in terms of the imagery that can give smarter understanding, views and targeting for ground-based robotics. So we've seen quite a lot of integration of targeting groundworks through the use of drones in the sky. So it's a way of just sort of pinpointing where you need to be focusing your efforts and your attentions. And yeah, we've got a number of options we can discuss throughout this that we'll go into a little bit more detail on that. In the mining and aggregates, we've got a couple of people in that sector with us today. So for you, obviously, it's going to be looking at things like the cut and fills, stockpile reports, and generally a way of understanding what is on site through the eye in the sky of a drone. Similarly, with topography and land surveying, we're looking essentially cutting down the amount of time spent with boots on the ground. So we've seen savings of upwards of sort of 80% in labour costs alone, where, you know, if you've got a large area that you need to cover and survey, exporting actual topographical data from that requires a significant amount of effort expended on physically walking around with survey poles, logging coordinates in sort of grid patterns, and well, yeah, we'll look at a few options with drones that can essentially cut down a couple of weeks' work down into a day's work. Similarly, in the remote inspection, we'll be having a look at different ways that drones can aid decision making, different applications, what sort of outputs we can be using, and yes, a little bit of an overview of what's possible. So one of the first things I'd like to talk about would be the technological developments that have essentially taken drones from being a sort of a cool idea 5-10 years ago to being a sophisticated survey grade piece of kit that can we're starting to see being used in everyday life to save time, money and effort all around. So one of the first sort of significant developments that's becoming more and more accessible daily is the improvements in obviously global positioning through satellites and RTK positioning. So with these, you're essentially saving the software for reconstructing your outputs a whole host of time and effort by narrowing down the uncertainty of the position of the craft. So all of the data outputs from UAVs currently that we provide will be tagged with GPS metadata, coordinates, and obviously adding this into your sort of processing workflow will mean that there's less uncertainty, less manual work needs to be done, and yeah, overall improves the accuracy and precision of your results in processing. So we're also seeing RTK not only being used in the output of drones, but also in the live positioning of the aircraft. So obviously all of the embedded metadata will be more accurate, but also the added positional accuracy of the craft can add a huge safety factor for when you're operating within essentially less kind environments, should we say. So for example, we've seen areas of inspection works where there have been high-rise buildings that have been deflecting signals. The solution to which would be to add an RTK station to add that extra on-the-ground positional accuracy. Battery life is another key development area as well. So essentially we've seen the flight time of commercial drones pretty much doubling in the last 5 years. So the area that you're able to cover with a UAV has been significantly technologically developed in the last few years. And yeah, this is obviously a huge factor if you're looking at using drones in your business. So not just technology for keeping the drone up in the air, but field power solutions have also been a significant advancement. And the number of commercial solutions that mean you've got the ability to recharge multiple sets of batteries from a device that can be easily fitted in a rucksack has significantly improved sort of the operational capabilities of drones. So obviously there's solutions both on the ground and in the air that can be used to make drones more viable for your business. Technology and sensors obviously is a given. So obviously as sensors improve, as does the quality of the data that you're able to capture. So we're seeing multiple sectors of development here, even in terms of things like proprietary payloads from manufacturers branching into new areas. We're seeing companies making essentially complete solution kits and able to essentially cover every sector that we previously discussed with a single aircraft, with swappable payloads, combination payloads. And yeah, as obviously the payloads improve, the data output improves as well, and what we can do with that. So finally, the usability aspect has been a huge gap that has been filled in the last few years. So drones are getting more and more user-friendly day by day. So seeing aspects of fully autonomous drones for inspection are starting to be employed and implemented. For those that want a more hands-on approach, you've got precise mission planning that can automate every single aspect of a flight, meaning you've got repeatability and consistency of your data captures, which is a very useful section for obviously capturing usable data as well as making the drones more usable. So user friendliness is a huge part of what we hope to achieve with Ether. As part of our MO is not just providing the equipment, but making sure you actually have sort of the tools that you need to be able to get the outputs you require, and yeah, make them as usable and user-friendly as possible. So in the next section, I'm just going to be discussing a brief overview of the capture types available, and yeah, essentially the sort of capture methods that we'd be seeing in the sectors that we've previously mentioned. So starting off with just standard photo imagery, RGB photo and video. This is a staple output for the staple capture method, sorry, for the renewables sectors, for housing, and anyone that's got interests in remote inspection. So obviously most people will be sort of immediately, this will be their first thought when they think of drones in the sky doing data capture. Their immediate thoughts would be obviously for filming and photo purposes. But yeah, we're seeing more and more creative solutions for actually making this data usable to businesses. So seeing platforms that make remote inspection accessible to any interested stakeholder in a business, from the pilot on the ground all the way through to the sort of the executive decision makers. We're seeing web portals and applications that will essentially enable you to physically move yourself around an inspection site, live view the imagery coming off of a drone from any desk anywhere. And yeah, generally the sort of the creative approach to making use of drone data of photo imagery is getting yeah, more and more sort of varied throughout these developments. So we're seeing the outputs of things like 3D photogrammetry being possible from RGB photo and video. So the reconstruction of 3D models. Obviously, 2D orthomosaics are a staple for geospatial imaging specialists, and obviously the photogrammetry data analysis side of things we can go into in the output section, but that's again one of the key sort of outputs we'll be looking at. Thermal imaging, we are seeing a lot in the renewables sector for inspections of thermal sites, as well as the applications for obviously search and rescue, electrical site safety for power stations. Essentially, the quality of drones, thermal imaging cameras, and the eye of the sky is near invaluable to businesses who are looking to make use of thermal imaging data. So not just in the not just in the inspection survey sectors, but obviously in search and rescue, incident responses too. So for LIDAR, a lot of what we're looking at in obviously the mining and aggregate sector is making use of LIDAR sensors. So for those of you for which LIDAR is a completely new field, it essentially will be a beam of light is sent out, the range is detected, that point is then recorded and sent back to the sensor. There's a lot of outputs that can be made use of in this one. This is a really versatile method of detection and sensing, but again, thanks to obviously battery life and the GPS and RTK positioning, has been made a really sophisticated survey grade tool that can be used sort of time and time again for reliable data output. As you can see on the screen, we've got a couple of examples of where it's being used for things like topographical surveys, the creation of digital terrain and surface models. So again, for the application of GIS and data extraction, updated local area mapping. This is a really powerful solution. So as we touched on earlier, multispectral imaging, this makes use of some set narrow bands of the spectrum of light to essentially capture non-visible light data. So we've seen red edge sensors and essentially combined multispectral and photoimagery payloads being used to get detailed sort of high detailed, high area coverage maps of crop health condition, of soil condition, and as I previously mentioned, in smart agriculture, there's been a lot of application of multispectral imaging for targeting areas of deteriorating crop health. So one of the key ways that we've seen savings in this sector, obviously, again, is the use of ground-based robotics integrating with data from UAV aerial capture. But we're finding more and more that sectors are not as sort of smart as they could be, and really are only just sort of dipping into the use of sort of technology away from traditional methods. The agricultural sector is certainly one of these. So hyperspectral imaging is essentially the next step up from multispectral. So where we have a set band of set wavelength band on the capture for multispectral. Hyperspectral will capture across the entire spectrum that is defined within the operating capabilities of the sensor. So these traditionally we've been seen mounted on satellites to track sort of widespread area environmental studies. But now obviously with the decreasing size of sensors, we're seeing UAV solutions that are sort of viable data capture tools being brought to market. So before we go on to the outputs that are obviously creatable from all of these capture methods, I just want to take a quick break and yeah, open the floor up to any questions that we've had on the actual physical captures. Okay, so no new questions so far there by the looks of it. Oh, can any thermal imaging sensor be used for thermal inspection? It purely depends on what the aim of the inspection is. So one thing that we will be discussing later on is the sort of the data standards output as part of flight planning. So I would say for thermal imaging sensors, minimum characteristics you'd be looking for would be a radiometric thermal imaging camera. This is because the usability of that data set is vastly improved when you have pixel by pixel sort of temperature data in the scene. So we've got a number of solutions from DJI that we will recommend in terms of thermal imaging cameras with a few third-party payload providers as well to tick the sort of the higher end boxes. But for those, the sort of performance aspects you'd be looking at would be the resolution of the camera for the output side of it. Obviously, the specific type of sensor as well will lend itself to how much noise is introduced to the scene. But yeah, these generally will we'll only really offer sort of inspection capable solutions for thermal imaging. So fingers crossed that's answered your question. So yeah, I think we'll move on to the discussing of the output section. So orthomosaics, these are essentially a perspective rectified projection corrected image comprised of a large set of images. So these combined with the sort of the GPS data from the coordinate reference system mean that you are able to get a top-down view or nadir view of the entire area covered by your mapping mission. So yeah, we're seeing a lot of these being used in the sort of geospatial sectors. So the creation of digital terrain and surface models can be done from these, but generally it is a tool for stitching together the entire sort of scene. So this can be combined with the RGB imagery. We can combine that with the multispectral and thermal outputs to create really sort of precise and detailed maps. And yeah, essentially these maps will be the foundation of the deliverable that you'd be providing to the sort of the end user of the data set. So preliminary sort of cut and fill can be done from these, digitalization of the maps, general sort of site overview, construction management, that sort of thing. And yeah, generally they're just a really good way of getting sort of the first sort of step of the imagery into the hands of the client to be able to see a full picture of what's going on of the area they're looking to capture. So adding another dimension to orthomosaics would be photogrammetry models. So as you can see from the graphic on there, this is the combination of photos to reconstruct a 3D scene. So there's a number of use cases that we're seeing from this, from the digitization and essentially just digital presentation of photorealistic 3D objects, to actually conducting remote inspection via these 3D models. So interacting with the photo set that you've taken to create the model to essentially generate a visual inspection from this. So seeing a lot of this taking place in the renewables sector, in the offshore oil and gas. There's been a lot of digitization work in the construction sector. And essentially these 3D models will be as accurate as the survey techniques used to capture them. So in terms of things like scaling and ground control points, there are a number of methods that we can obviously employ to ensure the accuracy of these, from the taking of known measurements through to the proper georeferencing of a scene. Yeah, really the only limiting factor is sort of how much coverage you can physically get of the object. But on that note, there are automated solutions that are currently being provided for 3D photogrammetry. So, for example, the model being depicted on this screen, there was no manual piloting involved in this mission. So this makes use of a fully autonomous 3D inspection drone that I'd be happy to disclose more details about if people want to hear more about that after the webinar. So sticking with 3D outputs, point clouds are obviously the natural progression. So this takes the output of the laser scanner and essentially displays all of those points in a sort of an understandable and useful manner. So with point clouds, again, we're able to really sort of dig into the scene. So they offer a full sort of overview of the scene in a very quick, concise capture. So they're really good for large area coverage without sacrificing any sort of precision or accuracy. Essentially, the outputs of these will be as accurate as the GPS positioning and referencing, really. So we'll see sort of some cheaper systems with lower quality IMUs providing accuracies of sort of around the 15 centimeter mark. But with LIDAR, this is sort of a get what you pay for system, where obviously the higher end systems with the better internals will provide a better quality of output all the way down to sort of 2 centimeter and with painstaking GPS referencing, even sub-centimeter accuracy. So seeing a lot of point clouds being used for volumetric measurements because of this. Obviously the stockpile measurement in the aggregate mining sectors. We're seeing a lot of them being used in forestry as well, in agriculture, purely for the vegetation penetration capabilities that LIDAR offers. If you have a split beam being detected by the sensor, depending on the quality of that sensor, partial returns will be detectable and can be used to sort of layer and start the initial classification of that scene. Combining photogrammetry and point clouds can be a really good way of digitizing and capturing reality accurately. So essentially, the collection of laser scans can be combined with a 3D photogrammetry model, essentially as a framework to overlay over. And this is essentially one of the methods that we can obviously discuss regarding getting the highest levels of accuracies out of the capture. So following on from the outputs of point clouds, terrain and surface modeling can be achieved using the sort of the multi-return aspect that LIDAR offers. So essentially, the two maps that you're seeing on the screen at the moment were captured by a 2-return sensor system. And even with just one partial return being sensed from the LIDAR scanner, we're able to see a clear sort of lay of the land in enough detail that we're able to generate accurate 5 centimeter contour lines on this scene. And yeah, really sort of display that in more detail than would be physically capable of capturing with traditional survey methods. So again, these are mostly being used for the generation of digital maps and in the topography field. We're also seeing a lot of this being used, again, as previously mentioned, in the mining and aggregates sector, but also in coastal erosion and monitoring of the sort of like the slip of buildings over time as well. So the accuracy of these can be obviously invaluable from a data capture perspective. So now we move on to the next slide. NDVI and NDRE. Now, these are essentially calculated outputs from multispectral sensors. So this is one of the key ways that the agricultural sector are making use of drone data. So this gives us a really clear overview of essentially a freshly planted crop scene on the left. So we're displaying essentially different levels of essentially chlorophyll content in the younger plants that are being reflected back into the sensor that obviously would not be visible to the naked eye, but a beyond visible light sensor will be able to detect. So this sort of output will give you a really detailed view of essentially of crop health. There are reams of national and openly accessible databases of sort of known values and indices to sort of compare these data sets from. So one thing that we're noting quite a lot of is obviously people know that there is this sort of capability of crop monitoring and health monitoring through the use of drones and multispectral imaging, but actually making that useful and usable to the client at the end of the day is where the sort of difficulty lays. So there are a number of tools that we can provide to make use of this data, sort of categorize and filter through to actually start understanding what's going on in the scene. Obviously, yeah, we can discuss in sort of like a one-to-one session if anyone is interested in hearing more about how specifically we can make use of the outputs from multispectral sensors. Cool. So obviously, first step in any UAV operation or data capture operation is the planning section. So those of you that are already well versed in drones will know that this will be a solid part of your operations manual. But essentially, defining the goals of the data capture are key to getting a useful output from the systems and sensors. So defining the mission objectives, what the area you're looking to capture is, what the sort of like the output specifications are. So things like ground sampling distance. So essentially the distance covered per pixel in any sort of digital output. Any sort of tolerances and accuracies. These will all inform the choice of aircraft and payload for a specific mission. So yeah, understanding the output that's required is obviously the first step. Selection of the aircraft and payload can mean the difference between obviously having a perfect mission executed first time to weeks of back and forth with the client, essentially trying to obviously rectify and capture when outputs aren't as required. So yeah, choosing the right aircraft and the right payload for the job is a significant factor in saving time and expended effort, and obviously ensuring the quality of the outputs. So this obviously encompasses everything from the kit that you'll be bringing out on site to the personnel that will be required for each mission. Generally speaking, in UAV operations, we see a pilot and a spotter as a bare minimum. But obviously in larger operations where large sort of ground control is required, we are seeing sort of upwards of 5-6 man teams heading out on site. Obviously this sort of scales as you look to cover wider and wider areas. But yeah, this will all fall under the sort of the operational considerations. So this covers everything from, obviously, is it safe to fly, checking out the classification of the airspace to make sure that you're not infringing upon any sort of local aviation authorities, and generally just taking on the best safety practices to ensure the safe completion of a mission. So next stage will be the preparation of the flight. So this will encompass everything from specifically planning out the mission capture area to everything including things like ground control, planning out things like your takeoff and landing zones, exclusion zones. So obviously when you, if you are using ground control points, factoring in the collection of the coordinates for that point has to be factored into the amount of time that you're spent on site. So there are a number of options that you can employ in terms of using your ground crew to obviously sort of maximize the efficiency of a data capture mission. So for example, if you have a pilot that has a half an hour worth of pre-flight checks to get through, including things like alerting local authorities before takeoff, contacting any air traffic control, which again will form part of best safety practices that should be covered by operations manuals. Obviously, collection and distribution of ground control throughout the capture area can be performed within this sort of window. So there are a number of tools that we can obviously employ when creating these mapping missions, ranging from the sort of simple equipment provider flight planning software that will be available through the controllers of the drone, through to complete ground control systems, which will be a way of automating large and complex flight missions, taking care of even the most sort of minute parameters of flight. So you can automate from the takeoff through every shuttle actuation all the way through. And this is a really good way of increasing the efficiency of UAV operations and obviously the consistency. So in the execution of a UAV data capture mission, obviously safety is absolutely paramount. And obviously if everything's been done right in the planning and the preparation, the execution of a mapping or survey mission yeah, should pose zero challenges, but there's always something that pops up. So yeah, in terms of the actual types of missions that we are seeing used across the sectors, so excluding manual automated, there's ways of automating everything that can be done manually with a drone currently. It depends upon sort of pilot's individual preference and the safety considerations around it. But the sort of like the key patterns and figures that we're seeing are single grid and double grid. So this is quite simply setting up the overlap of the capture area visible to the sensor and ensuring enough overlapping data to be able to fly multiple passes over a scene to ensure an efficient and effective data capture. Yeah, seeing a lot of corridor mapping being used for things like road and rail and power line inspection. So for this, it involves the establishment of a capture zone between essentially a start and an end point and any sort of turning points in between to follow the area or item of interest. Oblique inspection, we're seeing a lot of for things like photogrammetry. So this will be yeah, essentially the slight angling of a gimbal to provide sufficient parallax in a scene for 3D reconstruction and to provide enough sort of overlapping information to be able to accurately reconstruct the scene using photo imagery. And yeah, facade scanning again, we're seeing being used a lot in obviously the construction sector. There's a lot going on in the offshore and renewables sectors. So a facade scan is essentially a single or double grid, but flipped up on its side. So the sort of lateral progression of that is handled sort of vertically rather than horizontally. So the final step in a UAV data capture mission will be the processing. So there are a number of options that we can provide for processing of different data types. Obviously, specific equipment providers will have their own sort of inbuilt sort of product ecosystems that will encompass all of the processing between taking the captured data off of the drone and getting it into the hands of the client. So there are a number of options that we sort of can recommend for these. So when flying DJI drones, for general sort of all-round handling of DJI payloads, Terra is sort of the go-to recommendation that we will sort of stick with. So Terra, for those of you who don't know, is DJI's proprietary processing and flight control system for the Phantom drones, but it will also handle the processing of data from any of the M300 payloads, from the multispectral through to the RGB to LIDAR. Terra is sort of like your one-stop processing shop for getting the output of drones into the hands of clients. So for 3D reconstructions of a more specific nature, we generally tend to recommend reality capture. The workflows for these are all fairly similar in terms of extracting the data directly from the drone, in terms of the imagery that comes off of them. There will be an element of GPS correction, whether that's through ground control points, so simply inputting the coordinates that you've recorded physically on site and marrying those up with the ground control points in the image capture, or the ORTHOMOSAIC that's been created, or post-processing kinematics, which essentially take the same concepts of RTK positioning and just apply those to the trajectory in post-processing. So for these, again, reality capture is our go-to for 3D photogrammetry. Essentially, this takes the process of creating accurate 3D models from drone flights and essentially provides automated solutions for the majority of it, with very little manual type points and very little manual sort of work needed. They are introducing a 2D ORTHOMOSAIC tool and a mapping function, essentially again as part of sort of like an automated input the photos, click and go, and receive an output based on specifications inputted. But for 2D ORTHOMOSAICs and generation of things like multispectral and thermal data from a scene, we will still recommend Pix4D as the solution for this. In terms of obviously generating things for the more specific payloads, again, the equipment manufacturers will provide their own solutions for most of these for getting the best solutions and workflows out of it. These can be demonstrated essentially as and when they are needed in a separate meeting if that's requested by anybody. I think that concludes all of the material that I had to speak on at the moment.